So now that you've had a chance to graph some sine and cosine functions where you have changed only the period, let's change the period and also do a vertical shift. So remember that anytime we have a +1 or a plus d, this is always going to be a vertical shift, and it's going to happen to the y value of my original sine. It's the number attached to x here that changes what happens with the horizontal translation. So again, we have our general standard inputs, and for sine, our normal outputs. And so what we're going to do, at least to the output, is deal with the vertical shift first. And so to all of these, we're going to add one. Right. You're saying shift everything up by 1. And you can do that really quickly. Right. And then again, remember that when you're dealing with a horizontal shift, whatever is next to the x, you're actually doing the opposite. All right, and so remember that you're always looking at it in terms of, if I were to set 1/3 of x equal to 0, the way that I would solve for my new placement is to fraction bust or multiply. And so what we're going to do is we're going to multiply each one of these by 3. All right. And if you can simplify fractions, great. All right, if not, you're going to have to leave it as a fraction. So 3 times 0 is 0. Now when I multiply these across, I get 3 pi over 2, and then 3 pi. And then here is 9 pi over 2, and 6 pi. And so this is going to be my new placement of my x's. So now both the x values and the y values have moved. And so something you want to notice is that the gap, or the distance, between each of these intervals is the same. So from 0 to about 1.5, 3, 4.5, 6. That's going to help us a little bit when we look at our graph. Oh, amplitude 1, right? For our period, now the length of this interval is from 0 to 6 pi. Right? But again, I can think about it as 2 pi divided by 1/3. My domain is now going to go from 0 to 6 pi. Smallest value on my range is 0, largest is 2. And again, my midline is now changed to be 1. So whatever that vertical shift is going to help my midline. All right, so actually, let's make a graph. All right, and so this is going to be y equals the sine of 1/3 x plus 1. All right. And so depending on how you make your graph here, not sure how far out I'm going to go. So I know I need to go at least to 6 pi. So let's count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yeah, so I'm just going to do these as single increments. All right. And so this right here is going to be 1 pi. All right, 2 pi, 3 pi, 4 pi, 5 pi, which means 6 pi is going to come all the way out here. So I need to extend this a little bit. Okay. And so the reason I'm going to make this as large as I have is so that way I can do some of those fractional increments. And again, here's 2. And so I have some coordinates I need to graph. The first coordinate is the coordinate 0, 1. And again, if you want to, you could always put your midline on your graph first. So that way you make sure that you root 3 of those points at least on that midline. But then I get 3 pi over 2. And so 3 pi over 2 is basically 1.5. So this is 1 pi over 2, 2 pi over 2. Right here is where 3 pi over 2 is going to be. All right, so you can also think about it as the fraction 1.5. And since I labeled this 1, 2, 3, you can think of it that way. And so here we're going to go up to 2. And then at 3 pi, I'm back down here at 1. And then at 9 pi over 2, I'm at 0. All right, so 9 pi over 2 is right here, because again, that's like 4.5. All right. And then again, at 6 pi, I'm at 0. And one way that you can also check to see that those placements are correct is that you have the same gap between each of them. So there's a gap of 3 lines, 3 tick marks, 3. So there's a gap of 3 tick marks. So I know I've graphed these correctly also. And then we can make our graph go through those points. So nice, long graph. All right, so again, a normal sine graph, we've actually done that up here. All right, so a normal sine graph would have kind of, been right here in this area. And so this is the sine graph where it's stretched outward and it's also shifted up. And so a few of the problems we're going to do, that's going to happen where you're not changing the amplitude, you're not changing this gap, you're just changing the period and a shift. Right. So let's look at another one. Right. So for this one, right, what I'm going to do is it's a little bit hard to see, so I'm going to try to change this a little bit here, rewrite. But really, it's supposed to be the negative of cosine of 4x minus 2. And that's what I want to graph. And so in this case, I am going to have an amplitude adjustment. Right, so whatever happened to cosine, I'm going to have to multiply by a -1. And then I'll have to do a vertical shift as well. Okay. The other thing that I have to look at is this 4x, because that's going to be my period change. So all these little pieces, right? So again, for the period change, that means that I'm going to have to take all of my input values and multiply them all by 1/4. Because again, if I were to set 4x equal to 0, I would divide everything by 4, which is the same thing as multiplying by a reciprocal. And then my normal cosine values, right, I'm going to have to multiply them all by a -1. Right? And then when I'm done with that, I'm going to subtract 2. And that will give me my amplitude adjustment and my vertical adjustment as well. Right? So these ones that I'm highlighting are the change that's happening. Right? I'm going to do the same thing here. And I'm running a little bit tight on space, so what I'm going to do is actually write the times 1/4 on the right hand side. And you can do that if you start running tight on space on one direction. So it doesn't matter which side you start with first. You can either determine how the x's will change or how the y's will change. Here I have -1 minus 2, which is a -3. All right, or I'm going to have 0 minus 2. In this case, it's going to be a +1 minus 2, which is a -1. Right. -2, or again, -1 minus 2 is a -3. And so, okay, my absolute value of -1 is 1 for my amplitude. Now my period is 2 pi divided by b, which ends up being pi over 2 is my length. I'm going to wait on my domain for a second because I want to make sure, verify what's happening over here. But my range, my lowest y value and my highest y value, and then again my midline, is based off of my vertical shift. So my domain, all right, now I'm going to have to multiply everything by 1/4. And so what's happening over here is this is going to end up giving me a pi over 8, right? A pi over 4, a 3 pi over 8, and then a pi over 2. Okay. And so I can double check that my period length is a 0 to pi over 2, and then I can verify my domain. Okay. So these kind of help us a little bit with how to label our increments. right, when I start to make my graph. Right. Right. So again, that was minus cosine of 4x plus 1. I'm sorry, minus 2. Right. And so you're going to need to make sure you have more y values than x values when you create this graph. It doesn't need to be really big either. All right. So minus 1, minus 2, and minus 3. And again, I'm going to put my midline on here. All right, so let's look at this. I can make this right here. So if I want to, I can make this my pi over 8, skip pi over 4, right, 3 pi over 8, and then pi over 2. So if you want to stretch it out a little bit more, again, as long as you have the same gap in between your x values, you can do that. And so my first coordinate is 0, negative 3. My next coordinate is the pi over 8 and negative 2. And then pi over 4 and negative 1. 3 pi over 8 and negative 2. And pi over 2 and negative 3. And so again, you want to try to make a nice smooth curve. Okay. So again, you can see that negative reflected what our normal sine curve is. Right. So our normal sine curve looked like this. Right. And now I reflected it or flipped it upside down. Right. So keep working on these. Right. Keep trying to understand the differences between the amplitude, the period, and the vertical shift.